All right, buckle up, everyone. We're diving into some seriously cutting-edge AI research today.
Yeah.
You sent this over to us, and it's all about self-adaptive AI.
Yeah, right.
Specifically, a system called Transformer2.
Yes.
Clearly, you're looking to stay ahead of the curve.
Well, this
That's
is,
awesome.
it's an area that's moving so fast.
Yeah.
Transformer 2 is particularly interesting
Yeah.
because it tries to address some of the big limitations that we've seen with adapting large language models, these LLMs that we always hear about.
Yeah. Big ones.
Traditional methods like fine-tuning can be really resource intensive and
Yeah.
not very flexible.
It's like trying to teach an old dog new tricks.
It
You
is.
spend
It's a great analogy.
a lot of time and energy,
Yeah.
and it still might not get it.
Yeah, and Transformer 2 aims to change that
Okay.
with this clever two-pass system. The first pass is all about figuring out the task.
Okay.
It's like the model is asking itself,
Okay.
am I dealing with a math problem, a coding challenge, or maybe a creative writing prompt?
So it's sizing up the situation before it jumps in.
Yeah,
I like that.
right.
What happens in the second pass?
That's where the magic happens. Based on what it learned in that first pass,
Uh-huh.
Transformer 2 will activate specific expert modules.
Oh,
Think of it like assembling a team of specialists,
okay.
each trained to excel in a particular area.
Okay, so instead of one giant AI trying to do everything,
Yeah.
we have smaller, more focused AIs all working together.
Right.
Kind of like a team.
Yeah.
What makes these expert modules so special?
Well, one of the key ingredients is a technique called singular value fine-tuning, or SVF.
Okay.
Now, bear with me because this gets a bit technical.
Okay.
But
I'm ready.
imagine the model's knowledge is like a symphony orchestra.
Okay.
You've got all these different instruments
Right.
playing together.
Yep.
Singular values are like the volume knobs for each instrument.
Oh, I'm starting to see where you're going with that.
Exactly.
Yeah.
So instead of trying to change the instruments themselves,
Right.
which is what some other methods do,
Yeah.
SVF simply adjusts the volume knobs,
Interesting.
those singular values.
Yeah.
This allows it to fine-tune the orchestra for specific tasks without having to retrain the entire model.
That sounds incredibly efficient.
Right.
Like getting the same beautiful music with a much smaller effort.
You got it.
Yeah. And this efficiency has some major benefits.
Does it ever? What are they?
It significantly reduces the computational power and time needed to adapt the model.
Oh, wow.
This means you could potentially run powerful AI applications on devices that wouldn't have been able to handle them before,
Right.
like your phone or even smaller gadgets.
That's a game changer in terms of accessibility.
Right. Huge. Yeah.
What other advantages does this SVF approach offer?
So we have smaller devices able to use it.
Well,
Well,
the adjustments made through SVF are modular,
okay.
meaning they can be combined in different ways for even greater flexibility.
Oh, I see.
It's like having Lego blocks of expertise that you can mix and match
Yeah.
depending on the task at hand.
Oh, that's cool.
Need to solve a math problem,
Hey, AD?
write a poem.
Yeah.
Just combine the math module and the poetry module.
I love this.
Oh.
This is blowing my mind.
Yeah.
We're essentially talking about giving LLMs a whole new level of adaptability.
Precisely.
Yeah.
And there's one more crucial benefit,
Okay.
regularization.
Okay.
SVF helps prevent something called overfitting,
Uh-huh.
which is a common problem when training AI models.
Yeah.
It's like studying so hard for a test that you only remember the specific examples you memorized,
Oh, yeah.
but you can't apply the concepts broadly.
Blah.
SVF helps the model generalize its learning,
Oh,
even with limited data, so it can handle new situations effectively.
so it's not just a one-trick pony.
Yeah.
Right? It's got,
It can generalize.
it's got
Yeah.
broader knowledge.
Mm-hmm.
But we still need to train those expert modules to actually be experts, right?
Exactly.
Hmm.
That's where reinforcement learning, or RL, comes in.
Okay.
It's like training a dog with treats,
Yeah.
but instead of treats, we use rewards to guide the AI's learning process.
Yeah.
So the expert modules are directly trained on specific tasks,
Right.
like solving math problems or writing different types of code.
Yeah.
This means they're optimized for actual performance,
Okay.
not just theoretical metrics.
So instead of aiming for a perfect score on a standardized test, we're teaching these AI to excel in real-world scenarios.
That's a great way to put it.
That makes a lot of sense.
Yeah.
But how does Transformer 2 decide which expert module to use?
Right.
Does it just guess?
Not at all.
No.
Transformer 2 has 3 clever adaptation strategies to figure out what's needed.
Okay. I'm all ears.
Okay.
Tell me more about these strategies.
The first one is called prompt engineering, and it's the most straightforward.
Yeah.
The model analyzes the prompt, the
Mhm.
input you give it,
Yeah.
and tries to classify the task itself.
Okay.
It's like the AI is asking, what am I being asked to do here?
Right.
And then uses its answer to select the right tools for the job.
So the AI is evaluating the situation and picking the best approach.
Yeah.
It's becoming self-aware.
Right.
I love it.
Yeah.
What about the other strategies?
The second strategy is a bit more sophisticated.
Okay.
It involves a dedicated classification module
Okay.
that's specifically trained to identify the task.
Oh.
It's like having a super sleuth AI whose sole purpose is to crack the case of what kind of problem is this?
Okay, so we have the AI analyzing the prompt itself
Mm-hmm.
and a dedicated detective AI.
Yeah.
What's the third strategy?
The third one is called few-shot adaptation.
Okay.
It's a bit like giving the AI a crash course before it tackles the main challenge.
Right.
The system uses a small number of examples from the new task to further adapt on the fly.
I see.
Imagine you're learning a new language and you get a few key phrases to practice before jumping into a conversation.
That makes a lot of sense.
Yeah.
So it's adapting and learning in real time,
Mm-hmm.
which is pretty incredible.
Yeah.
But the real question is, do these strategies actually work?
Right.
Did the researchers find any evidence that all this cleverness actually pays off?
They absolutely did.
They did.
The research on Transformer2 has yielded some really exciting results.
Okay.
But before we dive into those,
Okay.
let's shift gears for a moment
Right.
and look at how this all fits into the bigger picture of AI research.
Okay.
There are actually two main ways researchers are approaching the idea of self-adaptive LLMs.
Oh, okay.
Okay.
So we were about to hear about those exciting results.
We were.
But first, tell me more about these two different approaches to self-adaptive LLMs.
Okay.
Yeah.
All right. So
Lay it on me.
you can think of it as a macro view and a micro view.
Okay.
On the macro level, researchers are exploring how multiple LLMs can work together,
Okay.
kind of like a team of experts with different specializations.
Yeah.
Imagine one LLM that's amazing at language translation,
Right.
another that's a whiz at coding,
Yeah.
and another that's a master storyteller.
I like it.
They could collaborate to achieve things
Yeah.
that a single LLM couldn't do alone.
So it's like assembling the ultimate AI dream team.
It is.
What about the micro view?
The micro view focuses on how a single LLM can adapt internally
Okay.
to handle different tasks.
Gotcha.
This is where Transformer2 shines.
Okay.
It's not about building a team of separate LLMs,
Right.
but rather giving one LLM
Yeah.
the ability to switch gears and become a specialist in different areas.
I see. So instead of multiple brains working together, we have one brain that can activate different regions
example.
for different challenges.
Yeah.
That's fascinating. But how does that actually work in practice?
Right.
How does Transformer 2 manage to be so versatile?
One key concept here is the mixture of experts,
Oh,
or
yeah.
MOE approach.
Moe got it.
Think of it like a company
Yeah.
with specialized departments.
Uh-huh.
When a task comes in, it's routed to the right department,
Right.
marketing, engineering, finance,
Yeah.
to get the best results.
Yeah.
In a MOE system,
Mm-hmm.
the LLM dynamically routes inputs to specific modules based on the task.
So different parts of the LLM are activated depending on what's needed?
Mm-hmm.
Is that how Transformer 2 does it?
Transformer2 borrows some of those principles,
Okay.
but takes it a step further.
Interesting.
Instead of routing at the token level,
Okay.
which is what many traditional MOE systems do,
Yeah.
it operates at the sample level.
Okay.
This means it considers the entire input,
I see.
the whole prompt,
Yeah.
to figure out which expert modules to activate.
Okay, so it's taking a more holistic view, considering the bigger picture, instead of just focusing on individual words or phrases.
Exactly.
That makes sense.
Yeah.
Are there any other key differences between Transformer 2 and these traditional MOE systems?
There is another important distinction,
Yeah, okay.
and it has to do with how those expert modules are created and trained.
Okay.
Remember how we talked about using reinforcement learning to train those expert modules?
Yes.
Well, in Transformer 2, those experts are specifically trained from the ground up to have highly specialized skills.
Uh-huh.
They each have a very specific purpose
Right.
and excel at their designated tasks.
So it's like handpicking and training an elite squad of AI specialists rather than just grabbing whoever's available.
Exactly.
Yeah.
And this focus on specialized expertise
Right.
is another key difference from traditional MOE systems where the expert modules might be borrowed from other models or trained without that same level of targeted specialization.
I can see how that would make a big difference in performance.
Yeah.
It's like having a team of world-class athletes versus a team of amateurs.
Right.
You mentioned earlier that SVF consistently outperforms other methods for adapting LLMs.
I did.
Can you explain why that is?
Well, one key factor is how these different methods handle adaptation.
Okay.
A popular method called LoRa, for example,
Okay.
uses low-rank matrices to make adjustments to the model's weights.
Okay.
It's like adding a lightweight plugin
Uh-huh.
to customize the LLM for specific tasks.
And SVF doesn't use these low-rank matrices?
Correct.
Okay.
SVF takes a different approach.
Got it.
Remember those volume knobs we talked about?
Yeah.
Those singular values?
Yeah.
Well, SVF focuses on modifying those singular values
Yeah.
within the full rank space of the weight matrix.
Okay.
This gives it more flexibility to make fine-grained adjustments,
Interesting.
allowing it to tap into the full expressive power of the model's weights.
So it's not just about turning the volume up or down. It's about adjusting the entire sound mix for a perfect performance.
That's a great way to put it.
I can see why that would lead to better results, especially for complex tasks.
Exactly. It's about striking the right balance between efficiency and expressiveness.
Okay.
Now, it's important to note that both SVF and LoRa draw inspiration from some really innovative ideas in AI research.
Okay.
They both leverage the concept of low-rank adaptation to make the fine-tuning process more efficient.
Remind me how that works again.
Sure. The basic idea is that instead of updating all the parameters in a giant LLM, which would be computationally expensive,
Yeah.
you focus on adjusting a smaller, more targeted set of parameters.
Right.
You're essentially finding shortcuts
Gotcha.
to make the learning process faster and less resource intensive.
It's like finding the most important levers to pull for maximum impact.
Yes.
So both LoRa and SVF are trying to do this, but they use different approaches to achieve it.
Yes, LoRa introduces those low-rank matrices
Okay.
to represent the task-specific adjustments, keeping the original model's parameters frozen. SVF, on the other hand, directly modifies the singular values to fine-tune the model's orchestra.
So both approaches are pushing the boundaries of what's possible with LLM adaptation.
They are.
But based on the research we're looking at, SVF seems to have an edge, at least for now.
That seems to be the case.
Yeah.
But it's an exciting area of research, and we're likely to see even more innovative approaches emerge as the field continues to evolve.
Speaking of evolution,
Right.
I can't help but wonder about the bigger picture here.
Yeah.
We've been focusing on how Transformer2 adapts on this micro level, but what are the implications of all of this for the future of AI?
Right.
Could these findings lead to a whole new way of thinking about how we build and share AI capabilities?
That's a great question.
Yeah.
And it's one that researchers are actively exploring in the next part.
Okay.
We'll delve into some of those potential future implications and what they might mean for the world of AI.
All right, so
Yeah.
stay tuned. We'll be right back after a short break. It's mind-boggling to think we're talking about AI systems that can essentially rewire themselves to become experts in different areas.
Yeah.
It feels like we're on the verge of a whole new era of AI, one where these systems are not just tools, but collaborators.
It's an exciting and challenging time for sure. As these systems become increasingly sophisticated and adaptable, we need to think carefully about the ethical implications and ensure responsible development.
Absolutely. What safeguards will we need as these systems become more autonomous? How do we prevent bias? Those are critical questions we need to address.
I agree. And as with any powerful technology, open discussion and collaboration are essential to guide AI development in a direction that benefits all of humanity.
Well said. Now, before we wrap up this deep dive, were there any other findings from the Transformer2 research that you found particularly intriguing?
Yes, there are a couple of things that really stood out to me. The researchers delved into the distribution of those singular values, those volume knobs we've been discussing. They discovered that relying solely on the most prominent singular values might not be enough to capture all the nuances within the model.
So even though those top singular values seem like the stars of the show, there's still valuable information hidden in the less prominent ones.
Exactly. This insight highlights the importance of finding the right balance between efficiency and expressiveness when designing these adaptation techniques. Some methods, in their quest for ultimate efficiency, end up relying on a very small subset of those singular values.
Which could mean they're missing out on subtle but crucial information that could limit their effectiveness.
That's a valid concern. It's like trying to recreate a masterpiece painting using only a handful of colors. You might capture the general idea, but you'll lose the richness and depth of the original.
That's a great analogy. It seems like there's a real art to this, finding that sweet spot where you can make things efficient without sacrificing the model's capacity to learn and adapt effectively.
Precisely. The other fascinating finding relates to something we touched upon earlier, the compatibility of those SVF expert modules across different LLMs.
Right. You mentioned that modules trained on one type of LLM could potentially be transferred and used with another. That opens up some incredible possibilities, doesn't it?
Absolutely. And the researchers wanted to understand what made this transfer possible. What they discovered is that the effectiveness of this transfer hinges on the specific way SVF modifies those singular values.
So it's not just a random adjustment. There's a precise method to the madness.
Exactly. SVF modifies those singular values in a very particular order, respecting the inherent structure of the singular value decomposition.
Now, this order is crucial for successful transfer.
It seems so. The researchers found that if you randomly shuffle the order of those modifications, the transfer becomes much less effective.
So there's something about that precise sequence of adjustments that allows the expertise to be carried over to a different model. It's like a secret handshake between LLMs.
That's a fantastic way to put it. This finding opens up exciting new avenues for research. Could we leverage this knowledge to create a universal library of expert modules that can be plugged into any LLM? It's a tantalizing possibility.
It's like having a universal toolkit for AI. Need an LLM that can write poetry. Just plug in the poetry module. Need one that can solve complex equations. There's a module for that too. It could revolutionize how we develop and deploy AI systems.
Imagine the possibilities. It's truly an exciting time to be following the evolution of artificial intelligence.
Well, this has been an incredible deep dive. We've gone from the high-level concepts of self-adaptive AI all the way down to the intricate details of singular value decomposition and cross-model transfer. It's been quite a journey.
Indeed, and I think the key takeaway is that the field is advancing at an incredible pace, and we're just beginning to glimpse the potential of these self-adaptive systems like Transformer2.
And for you listening, here's something to ponder as you continue exploring the world of AI. If we can transfer expertise between LLMs, could we one day transfer knowledge from an LLM to a human brain? Food for thought. This is the Deep Dive signing off.
Okay, so where were we? Oh, yeah. We were about to dive into the results of all this research on Transformer2.
Right.
You said they were pretty exciting.
They are.
Lay it on me.
Okay, well, one of the first things the researchers looked at was how well SVF actually performs
Okay.
compared to other adaptation methods, like LoRi.
Right.
And the results were impressive across the board.
Oh, yeah. In what ways?
SVF consistently outperformed LoRi
Interesting.
in terms of both accuracy and efficiency,
So it's not just better,
Yeah.
it's also faster.
and uses fewer resources.
That's a win-win.
Exactly.
So it seems like SVF is a more effective way
It does.
to adapt these LLMs. Now, you mentioned that Transformer2 uses 3 different adaptation strategies.
Yes.
Prompt engineering.
The classification expert
Yes.
and few-shot adaptation.
Right.
Did the researchers find that all 3 of these strategies work?
They did. All 3 strategies were effective,
Well,
but there was a clear pattern.
what's that?
The more information the system had about the task, the better it performed.
So it's a bit like us
Yeah.
humans.
Yeah.
We do better when we have all the context.
Exactly. Give the model a clear understanding of what it's supposed to do, and it will rise to the occasion.
Now, this is where things get really interesting.
Okay.
You mentioned earlier that these SVF expert modules
Yeah.
trained on one type of LLM could actually be transferred
Right.
and used with another.
Yes.
Did the research confirm that?
It did. The researchers found that these expert modules
Wow.
showed a surprising level of compatibility.
So you can train an expert module on one LLM and then plug it into a completely different LLM,
You got it.
and it still works.
And it still works.
That's incredible. What are the implications of that?
Well, it opens up some really interesting possibilities
Like
for sharing and reusing specialized AI skills.
Yeah.
Imagine a future
Yeah.
where we have these libraries of expert modules that can be easily plugged into any LLM.
So you could essentially customize LLMs on the fly
You could.
to perform specific tasks.
Exactly.
That's a game changer.
It is.
Now, I know we've been talking a lot about the benefits of this two-pass system, but I'm curious,
Yeah.
is there any downside?
Well, there is a slight time cost associated with that extra pass.
Okay.
It does add a bit of overhead
Right.
to the inference process.
So it takes a tiny bit longer to get a response.
But the performance gains
Yeah.
are significant enough
Yeah.
that it's likely worth it.
Well, this has been a fascinating deep dive.
It has.
into the world of self-adaptive AI,
It has.
Transformer2.
Absolutely.
We've covered a lot of ground,
Mm-hmm.
from the basic concepts
That's right.
to the technical details
Yeah.
and the potential implications of this research.
Mm-hmm.
So what's the big takeaway here?
I think the big takeaway is that the field of AI is evolving at an incredible pace.
Yeah.
We're seeing breakthroughs all the time, and systems like Transformer2 give us a glimpse
Yeah.
into a future where AI is more flexible, more adaptable,
Yeah.
and ultimately more powerful than ever before.
It's an exciting time to be alive,
It is.
and an even more exciting time to be following the world of AI.
Absolutely.
That's it for this deep dive into Transformer2.
Yeah.
For all of you listening out there,
Mm-hmm.
we hope you learned something new
I hope so.
and that you'll continue to explore the fascinating world of AI.
Me too.
This is The Deep Dive signing off.